Okay, this is the Unit 2 review packet. We're going to start with question number 1. Explain the relationship of the following terms: solution, roots, x-intercepts, and zeros. These are all the same. These are the places where the parabola crosses the x-axis. They all mean the same thing. How many solutions are there to a quadratic equation? So quadratic means it's got an x squared term. That means I could have either 2 imaginary or 0, 1, or 2 real solutions. So if I have 0 real solutions, that means I have 2 imaginary. And if I have 1 real solution, that means that's a double root solution, or I could have 2 different places where it intersects. Topic 7D, solve the quadratic equation by the quadratic formula. So this is questions 7 and 8. So the first thing you need to make sure is that your equation is equal to 0. So I'm going to do plus 16 plus 16. That gives me x squared minus 8x plus 16 equals 0. I'm going to identify my a, my b, and my c. So remember that my basic form of a quadratic is ax squared plus bx plus c. So a is the coefficient of x squared, b is the coefficient of x, and c is my constant. So the coefficient here of x squared is 1, the coefficient of x is negative 8, and my constant is 16. So now I do negative b, and you always need to substitute in parentheses, plus or minus the square root, again in parentheses, of b squared minus 4 times a times c all over 2 times a. And when I start to simplify this, I'm going to simplify it in 3 parts. I'm going to do this outside part. Negative times negative 8 is positive 8. Then I'm going to do my square root. And when I do my square root, I'm not going to put the square root sign. I'm just putting what's underneath the square root sign in. So negative 8 squared minus 4 times 1 times 16. There should be closed parentheses there. Do a quick check and make sure it looks like exactly what you have here on your paper. This is 0. So plus or minus the square root of 0 over 2. So the square root of 0 is just 0. So this equals 8 over 2, or 4. So this right here is a double root. That means that my vertex is on the x-axis at x equals 4. So this is one of the cases where there's one solution. It's a double root. All right, let's look at number 8. So again, this one's already equal to 0, so we can pick out our a, our b, and our c this time right away. My a is 2, my b is negative 52, and my c is negative 54. So I have negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. The outside gives me 52. Inside, I have negative 52 squared minus 4 times 2 times negative 54. That gives me 3,136. And all over, oops, this was 2, all over 4. So that's a really big number, but before I do a factor tree to simplify, I always check to see if something's a perfect square, and this is a perfect square. So the square root of 3,136 is 56. So this simplifies to be 52 plus or minus 56 over 4. So again, reminder, if they're big numbers, check them to see if it's perfect square. You could get the same answer by doing a factor tree, but it's a lot more work. So now I have 2 different things here. I have 52 plus 56 divided by 4, and 52 minus 56 divided by 4. So this one here is 52 plus 56 divided by 4 gives me 27. And this one is 52 minus 56 divided by 4. Well, that's negative 4 divided by 4, so that's just negative 1. So the 2 places that this one crosses is at 27 and -1. Let's do a little more talk about, let's look at 7E, quadratic equation by graphing. So again, it has to be equal to 0 first, because we're looking for the x-intercepts, which means y equals 0. So this is really saying the same thing as x squared minus 10x plus 25 equals y. We're looking for x-intercepts, y is 0. So I can use my y equals button, put that equation in, x squared minus 10x plus 25. I always like to hit graph first to see what it looks like. This one looks like it's a double root, and it looks like the double root happens at 5. I'm not really sure, so I'm going to go to my table, which is second graph. And again, x-intercepts means my y is 0. So right here I can see that yes, my y is 0 when x is 5. So this is x equals 5, and it is a double root. Now, if it had not been at the table, I would have had to go to second calc 2, and I would have gone left of this point. So I would have moved my little x here to be left, and I would have pushed enter. I would have moved it to the right and pushed enter, and it would have told me this 4.9999979, this is 5. And again, if you're not sure, check your table, but also we're definitely going to be rounding, so this rounds to 5 no matter what, but it is 5. You can substitute in to check, you can check your table, it's just 5. All right, the next one, it's already equal to 0, so we're good. We can put it in our calculator. So we've got 7x squared minus 3. Again, I like to look at it first. So it has 2 spots. It goes through here, not on a tick mark. So we're definitely going to need to do second calc 2 for zeros, and you're going to have to do it twice. I'm going to start with this point on the left. So I need to be left of it. So if I kind of get on the line and then push my left toggle, I'm left of it. If I get on the line and then push my right toggle, I am right of it. This tells me that one of my x-intercepts is -0.65, and we're rounding to 3 decimal places, so -0.655. That's that one. Second calc number 2 for the second one. I'm going to kind of put it on the x-axis, and I'm going to push my left toggle for left bound and push enter. I'm going to get back on the axis, put my right toggle and enter. I don't want the guess. So here it is 0.655, again rounding to 3 decimal places. So now on number 15, when it talks about a double root. So we kind of talked about that. A double root means the vertex is on the x-axis. So it would be something like this. So this means that the vertex is on the x-axis. That's what a double root is. And if you had factors, if you had it factored out, both factors are the same. So what I mean by that is, let's example, if I have this, x minus 4 times x minus 4 equals 0. Both factors are the same. That is a double root. It's one answer, x equals 4. Okay, so a graph that has 2 imaginary roots means it's never touching the x-axis. It would be up like this. I could have something like that, or it could be below. It could be something like this. But you can see these are never crossing the x-axis, and this one is never crossing the x-axis. So number 16, if the graph of a quadratic equation has its vertex on the x-axis, solution known as a double root. We just talked about this on number 15A. So again, this might look something like, let's draw one the other way this time. It could be going down. It could be something like that, where that right there is the vertex. It's on the x-axis, and it only touches in that one spot. If the graph of a quadratic intersects the x-axis twice, the solutions are real. So that might be something like this. It intersects here, it intersects here. There's 2 solutions. All right, number 18. If the graph of a quadratic never intersects the x-axis, the solutions are imaginary. So again, we talked about that. That means it's not touching. So it would be either going like that, or you could have it going down like that, but it is never crossing that x-axis. Number 19, what are the apparent zeros of the function shown in the graph? Well, zeros mean roots, which means solutions, which mean x-intercepts. And your x-intercepts here are x equals 1 and x equals -2, the two spots where it crosses. Number 21, find the discriminant and use to determine the number and type of solutions. So the discriminant is just that inside of the square root of the quadratic formula, b squared minus 4ac. So a, b, c. On this one, a is 1, b is -4, c is 10. So I have -4 squared minus 4 times 1 times 10. So again, when you put this in, you need parentheses. -4 in parentheses squared is not the same thing as -4 squared. So -4 in parentheses squared minus 4 times 1 times 10. Do a quick check. Make sure that you have the same thing here and here. It's negative. If the discriminant is negative, it means I'm trying to take the square root of a negative number, which means I have two imaginary solutions. And you can check that on your calculator by doing y equals and doing x squared minus 4x plus 10, hit graph. And you can see it never crosses the x-axis. It's up here going up in both directions, never going to cross. Number 22 is not equal to 0, so we need to set that equal to 0 first. -4x squared plus 20x minus 25. Now I can do a is -4, b is 20, c is -25. So again, I'm doing b squared minus 4ac, which is 20 squared minus 4 times -4 times -25. So in your calculator, you've got 20 squared minus 4 parentheses -4 parentheses -25 gives me 0. This means I have one real solution. It's a double root. It touches the x-axis at the vertex. All right, last one. This is already set to 0, so I can do a, b, and c. A is 7. There is no x. I could rewrite this as 7x squared plus 0x minus 3 equals 0. But there's no x, which means my b is 0, and then -3. So I have, again, b squared minus 4ac, so 0 squared minus 4 times 7 times -3. Well, 0 times anything is 0. This is positive 28 times, negative 28 times -3 is positive 84. Positive number means two real solutions. And again, you can graph these to check, and I would definitely graph all of these. 7x squared minus 3, hit graph. You can see it crosses in two spots. This one on number 22, I've got -4x squared plus 20x minus 25. You can see that it only touches, oh, I must put that in wrong. Oh, I forgot the x. -4x squared plus 20x minus 25, hit graph, and you can see it only touches in that one spot.